Coming up, we'll look at the new Azure Machine Learning service that gives data scientists the capabilities they need across the machine learning lifecycle within a familiar notebook experience. Now, we're going to show you how Azure ML makes it easier for data scientists to build reproducible experiments with machine learning pipelines and communicate operational dependencies to their engineering counterparts as part of a new MLOps approach as you deploy to the cloud and the edge at scale. And how you can use the newly introduced automated machine learning capabilities in Azure ML to build machine learning models in a fraction of the time. I'm joined today by Chris Lauren from the Azure Machine Learning team. Welcome.
Thanks. I'm excited to be on the show.
So Azure Machine Learning is a new service, but at Microsoft, we've been at this space for a while. In the past on mechanics, for example, we've looked at things like environments for data prep and experimentation and analysis using things like Azure Databricks, as well as various frameworks. But how do we think about Azure Machine Learning, this service, and really what's new and what's different?
In the past, if you wanted to use machine learning in production settings, you needed to bring together a bunch of different services to support the full machine learning lifecycle. For example, you bring together your storage, like Azure Blob Storage or Azure Data Lake Storage, because you can't train machine learning models without data. Bring in some compute, like individual virtual machines or a Spark cluster using HD Insight or Azure Databricks to run your code. And then to protect your data for enterprise readiness, you'd bring in your virtual networks or configure your compute and data inside the same virtual network and bring in some Azure Key Vault to manage and secure your credentials, for example. And then if you wanted to repeat your experiments using a consistent set of machine learning libraries and the different versions thereof, then you'd create Docker containers and use Azure Container Registry to store those Docker containers, and then put that inside your VNet. And then to run all that at scale, you might use Azure Kubernetes Service and include that inside your VNet.
Right, and this all sounds like a whole lot of stuff kind of to piece together to get the machine learning and all the models and everything to work.
Yeah, it is a lot to manage, and you spend more time managing all that stuff than actually doing the data science work. So with Azure Machine Learning Service, we remove that complexity for you. As a managed service, it comes with its own compute, hosted notebooks, and capabilities for model management, version control, and model reproducibility built right in. You can layer that on top of your existing Azure services. For example, you can plug in the compute and storage that you already have, as well as your other infrastructure services. Azure Machine Learning connects and orchestrates them within a single environment so that you have one end-to-end modular platform for your entire machine learning lifecycle as you prepare data, build, train, package, and deploy your machine learning models.
And as you mentioned then, for the data scientists, there's nothing to worry about there in that case. You're basically getting the services and everything configured for them and not having to compile all these individual services together.
Right. But the best part is you don't need to learn how to use new tools. You can use Jupyter Notebooks, your favorite Python editor like VS Code or PyCharm. And Azure Machine Learning works with any Python machine learning framework library like TensorFlow, PyTorch, scikit-learn, and more.
This is awesome in terms of making that lifecycle a lot shorter in terms of getting everything up and running. But for all the cloud operators and engineers running that, or maybe tenant admins, how do we ensure that our data scientists aren't consuming too much resource?
Yeah, because it is an Azure service, we have integrated role-based access control built right in that you can fully customize in any way you'd like. So for example, you can add a new data science role, so you can grant access to a data scientist, and you can simply facilitate them to run experiments but not create or edit compute, for example, so they can do their job without running up your bills in a way that's not approved.
Right, and the other cool part of the service is something brand new, MLOps. Now, this is a new concept for a lot of people. Can you explain what MLOps is and how it works?
So what really differentiates Azure Machine Learning is that we have an integrated DevOps approach for what we think of as MLOps. It makes it easier for data scientists and engineers to work together because engineers already have a good understanding of how this continuous integration, continuous deployment process works. And the data scientists know how to train great models. And so by enabling them to work together, we can ensure that we have high quality models at scale in production. With MLOps incorporated as part of the Azure Machine Learning service, we add experimentation. This means for data scientists that reproducibility is incorporated throughout the machine learning lifecycle in your training, test, and production environments. And they can create discrete pipelines for each model, making them easier to track and reproduce. For example, let's say you have a wind farm that you manage, and you want to ensure that you can both optimize the energy output and have a predictive maintenance scenario so that you can ensure that you can avoid any downtime. And so each one of these pipelines can help you consistently build, train, package, and deploy machine learning models to different windmills on the edge and iterate as new data comes in, new telemetry signals. So you can train and deploy new machine learning model versions to make sure that you have the best quality models in production.
Right, so this MLOps-centric approach then makes a lot of sense, but what do you do in terms of getting the service up and running for the first time?
So this is an Azure service. So you would simply go to your list of services in the Azure portal, log in just like any other service, and then you can search for Azure Machine Learning. You can select the workspaces here. And if you're just getting started, you can easily click Add and create a new machine learning workspace. You can see I have a list of available workspaces here already. So I can simply select one, and then I can see that I have a list of machine learning experiments that my team has been working on. I have a list of compute targets, whether it's like Kubernetes services to deploy my models or Azure Machine Learning Compute to be able to train my models.
Right.
And I've got a list of the models themselves as well, so I can keep track of what's deployed where and how well it's performing.
Okay.
Now, to get started on an experiment or to continue working on one I already have, I even have a list of notebook virtual machines integrated directly here. So those are like cloud workstations, if you will. So I can log directly into the Jupyter Notebook from the portal here, or access the URL directly and open a notebook that I've already been working on. You can see I've got a bunch of open source Python libraries like Pandas and NumPy, etc., and the Azure Machine Learning Python SDK, which I can install and use on my local laptop or use this cloud workstation as well.
Right. And the next thing is the notebook environment's really perfect for collaboration, and it's good to see that Azure Machine Learning effectively plugs right into that, and that it's a tool that I think most data scientists are used to. But can you walk me through then a real scenario and get some experiments and some models up and running?
Sure. So we've got Contoso Auto as a fictional car manufacturer here. And they're collecting IoT data from all their vehicles that they have deployed all around the world. Customers have bought and they're driving. But they're getting a lot of calls, a higher volume than normal, of complaints that they're having issues. Now we can drill into this Power BI dashboard that I have here. And we can see that for the different vehicles that I have out in the field, I've got an issue with starter motor. There's already a recall in progress. And I've got an issue with batteries. So I want to drill in here to see some issues. And I can see that I've got a higher than expected rate of failure for these batteries. So I'll show you how to use Azure Machine Learning to predict what kind of failures are likely to occur so we can notify customers proactively to bring their vehicles in for maintenance before issues happen.
Okay, so now then you can use these data points effectively, and like machine learning in general, it's really doing some predictions here in terms of customers in this case that might have a likely failure, so that we can call them before they end up on the side of the road needing to call a tow truck, which will be even more expensive for us.
That's absolutely right. So to get started with Azure Machine Learning for this scenario, first we need to connect to the Azure Machine Learning workspace. And again, that's the thing that's really bringing together my compute and data and everything all together. I'll create an experiment so I can iterate over and train multiple models and keep track of their quality score. And I'll get access to some of the data that I have available, that telemetry data that I mentioned. And I can register those data sets in Azure Machine Learning to make them really easy for my data scientists to find them. Then, using standard approaches in the Jupyter Notebook, I can interactively explore the data and get some intuition about what data might be useful to train a high-quality model.
Cool. So this is now where you might need to experiment with different models, but in classic machine learning with experimentation, this can take a lot of time, right?
It can, yeah. Typically, this could take days or maybe even weeks of experimentation, because you'd have to take the data set across the age of the battery, the temperatures, runtime, etc., and experiment with different algorithms and hyperparameters to train the model, and then repeat the process a bunch of times, because the scientific method is just kind of guess and check.
Right.
But now there's a better way with automated machine learning.
So can you explain how automated ML works?
Automated ML generates different experiment runs using a combination of different algorithms and hyperparameters and trains models in parallel, returning a quality score for each model after each run. Then, based on what it learns, it'll keep generating different experiment runs with different combinations of algorithms and hyperparameters to try to train an even better model.
So it's actually then using machine learning to select different experiments and really automatically, with that machine learning, find the right model for you.
Exactly. So now as a data scientist, you can focus more on fine-tuning the models versus a lot of the manual effort around trial and error.
But I can see where this might get expensive from a compute perspective. How does that work?
Well, it depends. Some models use a lot of compute cycles to train. However, this approach is more efficient because instead of your data scientists manually trying different combinations of algorithms and hyperparameters over and over, with automated machine learning, we can do this process in parallel, which in a fraction of the time to save you even more money. So for most data scientists, we're coming from a world where everything is running all the time. And so I might run a job before I go home at night, for example, and then the job might complete 5 minutes after I leave.
Right, and you're leaving that computer on all night.
Exactly. And so with AML compute, we'll automatically shut down the machines that aren't being used here.
So how's this all working then under the covers?
When I run an experiment, Azure Machine Learning will take these different experiment jobs and insert them into a queue. Right? And then as the queue forms, this kicks off automatic VM provisioning in the cluster. So the cluster starts off with 0 VMs in it, then it grows kind of on demand as a workload increases.
Makes sense.
And so then we can run as many jobs in parallel as we allow from that compute quota limit perspective. And then as those VMs get saturated, the remaining jobs stay in the queue. It'll drain the queue after jobs get complete. It'll pick new jobs. It'll train the models all in parallel. And then as we drain the queue completely, then we'll automatically deprovision the virtual machines so you don't pay anymore.
So it's truly elastic. That cluster had been paused effectively, it provisioned everything out, and then it contracted and paused again when you were done.
That's right. And you still have the full flexibility of configuring or choosing what VM SKUs you use. So you might use some with GPUs, for example, to facilitate deep learning jobs, or pay for CPU VMs, which are less expensive if they're more appropriate for your workload.
All right, so the concepts make a lot of sense, but can you show us this in action?
Yeah. So to run those machine learning jobs in the AML compute cluster, first I'll grab a handle to this compute target, which has already been created, but I can create it from the Python SDK here in Jupyter if appropriate. And then I'll create an automated ML config file that specifies that this is a regression task because I'm using that data to predict how far in the future the battery is likely to fail. And I can set some constraints to control my costs, like how many models or iterations do I want to run and how many of those should run in parallel, how long each of them should run for, so I can control my costs.
It's like your config parameters file, yeah?
Yeah, exactly. And then I'll run this by calling experiment.submit. And then I'll grab a handle to the run object, and then I'll visualize it directly here in the Jupyter notebook. And I can see that Azure Machine Learning ran a bunch of these in parallel. I can see the quality scores and details about each one of them with a nice visualization. I can see that there's a clear winner here based on the metric that I've chosen.
Right. And the darker green meant that was the best model run. So now how do I go about taking it to the next step where I want to package them up and get them deployed?
So this is one of the best parts of the Azure Machine Learning service. It's super easy to operationalize your models and deploy them in production. Here I can take this machine learning run, I can grab the best one of those iterations automatically, and then I can publish that to the Azure Machine Learning Model Registry. But just by calling register model, I can give it some tags and descriptions. And then when I do that, I'll actually see that in the workspace here. I can see the list of models. And so this is the model registry. And so this is how I know what models my team has and what models I might want to deploy. And even see where some characteristics about each one of those and see where they're deployed. So in this case, this one is deployed to an Azure Kubernetes service. I can even drill into the details of that Kubernetes service deployed model, where I have a REST API, I can get the scoring URI, I can recycle the keys for security purposes if I want to, and that sort of thing. But let me show you how easy it is for a data scientist to be able to deploy this. We simply create a scoring file which runs the model, and then I can package that up with my dependencies that I need, and this will generate a Docker container for me that I can then deploy to my Kubernetes cluster by using this inference config and just specify my scoring script and my dependencies YAML file and then call model.deploy. Once it's deployed, then I can test this out and I can get the response from the REST API endpoint that we automatically generate. And then I can integrate that with my Power BI dashboard. So instead of just a list of potentially affected vehicles, then I actually can get the predictions by using that REST API endpoint. Not only can I get the predictions, but I can even get the list of the predictive features that explain why that model chose those particular vehicles. So when I call the customer to bring their vehicles in, then I can explain to them what characteristics picked them, if you will.
So this looks really powerful, but what if I'm not familiar with things like Jupyter or I can't write Python? Are there things I can do that are a bit easier to get up and running?
Yeah, we hear that a lot, and that's why we created the new user interface for the automated machine learning
Okay.
experiments to get started. So here you can see I've got a history of the recently run experiments, but I can also simply click Create Experiment. And this will create a new experiment run, either in the same experiment or a new experiment. I'll select the same one I was using before here, and the same compute cluster that I was using as well. I'll click Next, and then I'll be able to choose the data that I was using, and then I'll be able to get a quick preview of it. I can select the type of task. Again, this is a regression task. And I can select the column that I'm trying to predict because I want to find out how long it's likely to survive in days, right?
Right.
So click Start. And through that kind of wizard-like approach, then we can train new machine learning models. However, while this is running, I can even go into some of the details of recently run experiments where we can see some of the characteristics, and we can even easily click Deploy the best model, just like I did in the Jupyter Notebook earlier, which will register the model in the machine learning model registry.
Okay, so you can track then everything in one place, but what helps then with things like reproducibility? You mentioned earlier that we're using things like ML pipelines. How do those actually come into play here?
Yeah, let me show you how we can use the same sort of approach that I just mentioned and automate the process of training unique machine learning model for each different type of car, year, make, and model that I have. So we can see I just created a list of the different makes and models. Then I'll create my AutoML config file specifying the type of task again. And then I can create these different steps in my pipeline to run the AutoML experiment, collect the best model and the key metrics out of that, and then assemble them together in a pipeline where I append a bunch of steps. So you can run these in serial or in parallel. And this is super important because sometimes in a machine learning experiment, there can be tens, hundreds, or even thousands of unique steps that I need to run. And so by creating a pipeline that I publish and I can just run it on a schedule or by calling a REST API, then it abstracts all of the complexity inside the pipeline so that I can just run that in a for each loop for all the different makes and models, if you will.
So this all totally makes sense in the context of the notebook.
Yep, and from the Azure portal, I can also see the inventory, the list of pipelines that I have. I can schedule them to run. I can see the details about them as well, like who created them, the REST API endpoint, so that I could call them and see all the steps that are in each pipeline.
So nice visible and visual view here that you've got. Now, you mentioned earlier that you can also integrate with things like Azure DevOps. How does that work?
Yeah, it works in two different ways, build pipelines and release pipelines. The build pipelines integrate with Azure Machine Learning pipelines to facilitate training and building that model. You can think of that model as like a build artifact. So here I have a build pipeline that then runs the ML pipeline that I mentioned earlier. And then once that machine learning model is built and registered in the Azure Machine Learning Model Registry, then that will kick off the release pipeline. So we can see it's going to either run when you check in maybe a new scoring script or a new version of the machine learning model. And then we can have multiple tasks in this test. So it can run in, say, Azure container instances, and then it can run a bunch of different integration tests with my application, as well as quality tests to make sure that the model is good. And then once that's done, then it can roll this out to my Azure Kubernetes service, which will, again, deploy that, but not until, for example, we've incorporated a human in the loop for deployment approvals to make sure for auditory, compliance, regulatory type of reasons that we know exactly what we're deploying and have proper approvals.
Right, so this is a release pipeline. You can kind of do anything with it. And basically, you can even have things get deployed out to the edge if you wanted to with the same release pipeline. Now, one thing that's great for data scientists that are watching, and we mentioned earlier the integration of things like, for example, deep learning models with TensorFlow, and you can also use machine learning then to go beyond the predictive models that we just showed here. What would we do then in terms of taking it to the next level and maybe using some different data input types to do deep learning?
Yeah, so for example, if you had a camera installed in the car, you might use that video telemetry stream to then train a model to identify whether drivers are distracted, for example. And so we can take those images, train a model using PyTorch or TensorFlow in the cloud, make sure that it's good, then use IoT Hub to roll it out to the individual cars, and then you can maybe raise an alert in the vehicle if a driver is doing something that's unsafe.
Maybe that they shouldn't be doing. So really, really good stuff. So this is an awesome intro in terms of all the different things that you can do with DevOps as well as MLOps and all the Azure machine learning services that we've just rolled out. Where would people go to learn more on how to start using all of this stuff and really consuming it?
Try it yourself. That's the best way to get started. You can learn more at the link shown.
Really great tips, and this is a space that continually evolves and changes. And of course, you're going to want to keep watching Microsoft Mechanics for the latest tech updates across Microsoft. Hit subscribe if you haven't already, and we'll see you next time.